Hello, everybody. My name is Evie Bosset from the Iridium Network in Antwerp, and I will present to you our results from the Seafarer study for patient-specific QA. Now, what is the Seafarer study? It's a multi-center investigation where small but clinically relevant errors are introduced into DICOM files. Each center then applies its own patient-specific quality assurance procedures to assess whether significant deviations can be detected. During the process, centers do not know which errors have been introduced nor how large the deviations are. Only after submission of the results, centers receive feedback. The study is open for head and neck and spine, and just today I received message that also a multi-med brain SRS study has been launched. In this link, you can find the paper describing the methods of the Seafarer study. There are some examples here about the introduced errors, and if you look at our current tolerances for the MPC, you can see that the introduced errors are very close to the current machine tolerances. But here you can also see the impact on the PTV, the brainstem, and the spinal cord doses for head and neck and for spine, and these can be quite large. Now, already more than 160 sets of results have been submitted across 13 countries. And if you are also interested to participate in the study, you can just scan this QR code or send an email to Lauren May. They have found that sensitivity and specificity is much more depending on the workflow and on the used parameters than on the PSQA device itself. A paper presenting their results for head and neck has just been published, and you can find the link here. Our current PSQA workflow consists out of measuring with the EPID using integrated images and do an automatic analysis with per fraction. For the regular VMAT, so including our head and neck plans, we use a global gamma of 3% to millimeter with a threshold of 10% and a passing rate of 98%. For SBRT and SRS, including the spine, we use the universal metrics, so we calculate three metrics at the same time with a local gamma of 3% 2 millimeter, a local gamma of 5% 1 millimeter, and a global gamma of 5% 1 millimeter, all with a threshold of 20%, and again a passing rate of 98%. For this study, we also added an extra analysis using the global gamma of 3% 1 millimeter. If these results are failing, then we visually inspect all results, the profiles and the 2D images. We sometimes analyze with other gamma metrics like 3% 3 millimeter or 4% 2 millimeter. And if needed, we ask the approval of a radiation oncologist or we make a new plan. Now, these are the results of my personal evaluation of the Seafarer head and neck plans using these parameters. When we consider 5% as clinically acceptable, plans within the black square should pass. The inner circle represents, the color of the inner circle represents the proportion of the submitted results passing or failing PSQA. The outer edge color indicates our result. So you can see that our submitted results were perfect. But because I thought it was a very interesting exercise, I asked all physicists in our center to do the same. And these were the results. So you can see that even with the same data, people evaluated other plans as acceptable. This shows how large the user dependence is and how important education, experience, and exercise is. These are the first three plans for head and neck. The original plan on the left, then a plan with a small overdosage and one with a small underdosage, which you can clearly see also in the profiles. The next three plans clearly show a quite large overdosage. You can also see that the introduced errors cause relative overdosages to the brainstem and the spinal cord about twice as large as the ones to the PTV. Here, the first two plans have large underdosages, but in the last plan, the deviations are only in low dose areas, and the PTV and the organs at risk are not largely affected. These two plans both just fail with 3% 2 millimeter and a 98% passing rate. And they pass with 4% 2 millimeter and 3% 3 millimeter. So I looked at the profiles and I decided to fail the first plan, but to pass the second, because in the second plan, deviations are again scattered in low dose areas, while in the first plan, they are concentrated in a central area, so probably affecting the deviations to the plan a lot more. So having an orange area with an in-depth analysis is useful. These are the results for the spine plans. You can see that again, our evaluation was quite okay. We passed only one plan that should have just failed. The PTV dose was within 5%, but the spinal cord dose was more than 5% overdosed. What I also noticed is that small MLC bank deviations caused differences twice as large in spine plans than in head and neck plans. These are all plans for the spine that are clearly passing. These are the plans that are all clearly failing. And then these are two plans that are in the orange zone for 5% 1 millimeter local, but having only a small underdosage. This is acceptable for a spine plan. These are three plans that should all fail if you look at the spinal cord overdosages. But the first plan here is that one plan that should have failed, having a spinal cord overdosage of more than 5%, but a PTV overdosage of less than 5%. So this one was not detected. The second and the third plan have quite large overdosages, but these are only detected with 5% 1 millimeter local and 3% 1 millimeter global, not with 3-2 local or 5-1 global. I will share with you the introduced errors in these first two plans. In the first plan, the MLC bank is 0.5 millimeter open. In the second plan, the MLC bank is 1 millimeter open. I also repeated the test for these plans on a different TrueBeam STX, which gave the same results. And I repeated the test with energy 6x instead of 6FFF on the TrueBeam STX and on a regular TrueBeam. These are the results. For all the tests, the first plan is still passing. So we can only conclude that our testing with perfraction with these gamma parameters is not sensitive enough to detect a 0.5 millimeter open MLC bank. But if we would introduce even tighter metrics, we would also create false positives. And for the head and neck plan, an opening of 0.5 millimeter of the MLC bank did not introduce errors on the spinal cord of more than 5%, but for a spine plan it did. So we should be aware of that. The second plan, when the MLC bank was 1 millimeter open, did produce deviations that were detectable, but on the STX only with 5% 1 millimeter local or 3% 1 millimeter global. On the regular TrueBeam, this plan did fail with almost all gamma analysis parameters. It's currently not clear why this difference exists. This is still under further investigation. And then finally, we did the same exercise for ArcCheck, but it was not possible to define criteria that eliminated both false positives and false negatives, not even with an orange area. We do not have a lot of experience with ArcCheck, so possibly there were some calibration issues. As can be seen in the publication from Lauren, there were centers that also achieved good results with ArcCheck. So I will not elaborate on our personal results for ArcCheck. So to conclude, small MLC bank deviations cause differences twice as large in spine than in head and neck. A correct evaluation of plans is not easy, and performing a Seafarer study can help evaluating analysis parameters and setting up education and exercises. Perfraction provides high sensitivity and specificity for detecting clinically relevant deviations in treatment delivery. For head and neck evaluation, using a global gamma analysis of 3% 2 millimeter with a threshold of 10% and passing rate of 98% is efficient. For evaluation of SBRT spine, that should be done with at least 5-1 local or 3-1 global. We found 5-1 global or 3-2 global or local not sensitive enough. An orange area, if failing these criteria with an in-depth analysis, is definitely useful. And deviations on the PTV can be correctly estimated based on the profiles, but deviations on the organs at risk are sometimes underestimated. In our study, ARC-check reliably detected only large deviations, and it was not possible to define criteria that eliminated both false positives and false negatives, but the lack of experience may have contributed to the lower performance.